Hi guys, welcome back to the channel. Today I'm going to explain how to do turn-based movement with a first-person perspective. Now this is perfect for a Gridder style dungeon. You might have seen my procedural dungeons in my last couple of videos. Now we're building a perfect movement system for that. First-person perspective, turn-based, really cool for our procedural grids. So we've already got set up to 400%. Or 4 times cubes there, which is exactly the size of one grid space. That's to test movement later. And we've just now also got a default cube, which is going to basically be our player in the middle, perfect center of a grid cube. I've put a big old microchip on there that can easily be seen, and I've scaled up the microchip just for easy access. And we need a controller input. Now this is basically the brain center. It's going to, amongst other things, allow us to read the controller input when that cube is possessed. You can easily automatically possess it as well, but I'm just going to leave it as possession manually. Alright, so I've put a camera object on the microchip. There is a camera setting in the controller as well, but this one's just a bit easier to tweak. As you see there, I've tweaked it so it looks like a good first-person perspective. Now, I'm going to try it out, but first you'll notice there's a stay on screen and off screen indicator by default on. Now what happens when we possess our cube, you get this weird little flash, and then, we've respawned. And it's actually going to keep killing the cube because technically it's off screen. We're looking from the perspective of the cube, but the cube itself is off screen. So that's took me a while to figure out, and to save yourself the frustration, click those two little features off for any time you're using first-person perspective. Alright, so we're going to start to build the turn-based system here, and we do that with a microchip within our microchip, which kind of essentially becomes a function like in code or programming. It's got a set of logic which we can repeat across all 4 turns. So the vital elements are an AND gate, because we're checking 2 things at the same time to be true. We're also going to need a timer, which will be set to half a second exactly. There's some precise timing and movement in this to retain the grid-based orientation of the player. So we've got an AND gate, a half-second timer, and a NOT gate. And the NOT gate kind of comes in handy a bit later on. Basically, we need to test when the timer is running, and the only thing we can do that through is a signal of when the timer is finished. So when it's not finished, i.e. it's running, we're going to get a signal to make the turn. Okay, so I've copied 4 of those microchips across in the kind of roughly correlating to the position they are going to send our character. So we'll do the top one first, and we're going to test for the up button on the D-pad. So it's just a simple D-pad movement. Up's going to send the character forward. So basically we're checking. We start the timer in a finished state. So basically a turn is not being taken. There you go. We can just drag that timer across. So if we get someone pushing up and the timer is in a finished state, rather if the signal is not in a finished state, because we've got the NOT gate there, we're going to run the movement. And it's kind of important that we have the movement just for that 1/2 a second as the timer is running, because that's going to enable us to be precise. We're really lucky that Dreams has a good metric system, and it's quite accurate. So if we run it for 4 meters a second for 1/2 a second, it'll move exactly 2 meters, which is great, wonderful, in fact, because 2 meters is the cubic grid size on the default ruler that we see, there behind the action on the flat plane of the default creation. So we'll up the damping and the strength just so we don't get any kind of inaccuracies or little odd things with the movement. We want it to be clean and crisp as possible. And actually, to be honest, I think that there might be merit in putting the snap to grid, or there's a gadget that you can put on a controller or an object that means when the player's moving, and it will stay on the grid. I haven't had luck all the time with that, but I think it could potentially help. Alright, so we're going to test forward movement. It's working there. We've got forward movement. That's great. Now all we need to do, go back, reset it. We'll repeat the process for D-pad down, which is going to be backward movement. You can see we've already got most of that logic set up. We can actually just duplicate that. It's already got the strength and damping setting set up. It's already got the speed right. We just need to turn it to negative so it's moving backwards rather than forward. I really prefer to use a negative speed as opposed to shifting the mover around completely. I just think it leads to a little more accuracy. Alright, so once again we're going to repeat the process. We've got D-pad down and our timer is finished. We're going to reset the timer, start it running, and while it's running we're going to move it forward. Oops, we lost our NOT gate there. There we go. So a few little things you need to tweak around, but it's pretty simple. That's not going to work. I think I accidentally set it to just trigger the movement from the AND gate, which isn't really going to work. It has to come off of the is running logic. See there, you've got the AND gate feeding into the NOT gate directly, which is going to basically be all the time. Unless you quickly tap, it's going to stop for a second, but the timer wasn't set to finish either. Sometimes when you get a little problem with your logic, it's best just to clear all the wires and start the logic again. I think that's what I do here. Oh, still not working. So again, go back in. Never stop making that mistake of clear all the wires. Start fresh. Never not make the mistake of hitting square instead of X on a microchip. It's funny that, you know, it opens up the settings on anything else, but when you've got some of these like timelines and microchips, there's both settings and, you know, I guess the board itself. So just repeating that the right way this time. So D-pad down plus timer's finished, reset the timer, and while it's not finished for half a second, we move it backwards at exactly 4 meters a second in reverse. Should now work. There we go. We got a perfect grid movement forward and back. Looking nice. So the next step is to allow rotation. This is going to be first person without strafing. We're just going to turn around to move in 2 dimensions, I guess. Not 3-dimensional movement, 2-dimensional movement, which makes it great for like a top-down isometric or just straight top-down dungeon crawler roguelike in the vein of NetHack. The difference is that local space, which currently I haven't tweaked the local space. Local space isn't used if you're going top down. It is used if you're doing first person, because as the cube rotates, which we're going to set up now, it's going to change the way that those movers send the object. So the logic for left and right is identical. Again, we want really strong, crisp movements. We do want local space, and we want that on the other 2 movers as well. We need to adjust the plane of rotation. By default, it's going to kind of tumble it like a forward roll. Instead, we want it to shift around on the flat plane so that it's just making a nice 90-degree turn. And again, we've got a really great thing with the rotator here. The default is 180 degrees per second. We want it to turn 90 degrees, which means we don't need to change the setting because we're running it for half a second. You know, those movements should be really crisp and theoretically should retain our grid. So we're going to wire this up, left turn first because that's the way it was spinning. If we get D-pad left plus, timer's finished as a signal, we're going to reset the timer. And when it is not finished or running, it's going to do the rotation. Now, if you're astute and thinking ahead, you may notice a little issue with this, is that all of the timers are being tested separately. So each of the D-pad movements is on its own turn and its own timer, and theoretically you can cause some real trouble by mashing buttons and getting us out of alignment. So we're going to fix that up in a second by making one bigger check so that all the timers are being checked. All of the 4 timers are being checked for each turn movement. We'll do that in a second. Just first quickly have to make sure everything's in local space. You might have seen the error there that it was not moving the way that we turn. You do need to adjust, once you're in local space, you do need to adjust to make sure that it is lined up. The cube, the shape actually has its own sort of default local space, I think. I started out doing a sphere for this character, but the sphere tends to have really weird, unpredictable local space, and I found it impossible to get that local space movement to snap to the grid perfectly forward. So, you know, the cube's just easier in the end. There's no reason not to use a cube. It's not a visible object at the end of the day. Okay, so we're just going to repeat this process with our right turn. Just copy that rotator across, and again, just like movement forward and backwards, the easiest trick to getting the reverse true is just use negative numbers as opposed to changing the rotation. Far simpler at the end of the day to do it that way. I don't know how I've lost my NOT gate. So we're using our right input. I will upload this, or I'll make this public and remixable for you guys, so that you can have all this wiring done if you couldn't be bothered, and you can just grab the cube and drag and drop it into your stuff. I'm not sure it's the perfect solution, but it's quite a simple one and a quick one, and hopefully you understand it after I've spoken through. One thing I would like to figure out is how to have one central turn timer rather than 4 independent turn timers. As I said, this can cause some problems when they're independent timers. I've got a little workaround that I'll show you in a second. It feels like it would be better to me if there was one central timer, but because it's running different movements, it might be hard to differentiate. Any ideas, let me know, and have a look at the wiring yourself by checking out indreams.me/bsjez. Alright, we're going to just change the rotation, negative number, so that it can, again, just make it negative and there's no need to realign it. Here we go. We should be pretty close now. We've got local space on. Somehow my cube got turned around along the way, but it's all good. There we go. We've got first person movement, grid based. We're staying on the grid, I believe, at the moment. But we can move through those blocks, and this is where the blocks come in. That's a physical object, but there's no check against the existence of a space there. So we have to solve that problem. That one's pretty easy. And we also need to solve the problem of the fact that if you look now, I was mashing some inputs there, and it's put me off grid because because each timer is independent. We can move forward and rotate at the same time, putting us off grid. So we need to check basically all of the timers against all of the other timers. So we're going to have one big AND gate on the microchip. So when we test for the timers finished, instead of testing this timer's finished, we're going to test all timers are finished. So all 4 of those timers must be finished. So we can delete that wire, not that one, we can delete that little A wire for the timer's finished, that signal wire, and instead of feeding it there, we feed it into this big AND gate, which is going to test all the wires. So left timer's finished, forward timer's finished, right timer's finished, and back timer's finished. We can fairly efficiently wire that up. If we can get the angle. I'm never much good at organizing my screen space. It's a funny one. There's benefits to this really physical, visual style of coding. You know, as I said last time, a lot of my ideas, because I can picture the logic as an image rather than as a set of words on a page or a language, it actually leads to some great solutions while you're just thinking about the game rather than playing with the game. You know, you can perceive internally, visually, a solution to a problem. But it also means there's a little bit of inaccuracy. You've got layers on layers of logic. It's kind of a tangible thing, and it's prone to problems with the tangibility, you know, like having something hidden behind something else, or just the precision of three-dimensional space, I guess, being tricky. Okay, so this should be working. Basically, I just made that AND gate. Everything tests against everything else. Now I can pretty much mash all my buttons all at once, and I'm still only going to take a single movement every half a second based on what's pressed as soon as all of the timers are finished, or any of the timers are finished. I can keep smashing that, and theoretically I should be on grid. Looks like it's a little bit off, maybe? Yeah, my rotation, I'm not sure what the issue is there. I might go back and tweak it. I do think the logic is sound. Maybe I was off grid a bit to start with, perhaps, or my rotation was off a little bit. I don't know. I'm just going to set it back to the grid. And if you can perceive an issue with this logic that might lead to me losing the grid, please let me know in the comments if you got a more elegant solution. What I like about this is it's quick, it's fairly simple. You know, it gives us that nice little first-person grid-based dungeon hack style movement. And now all we really need, in fact, all we need at all, is to not run through those walls. And we can do this really simply with a laser scope. The laser scope's really awesome gadget. It'll just tell you if there's something in its path, visually, essentially. So it shoots out a little laser, and we can just check the forward and backward movement against the laser scopes. Now you'll notice that I didn't put them on the microchip. I put them in the kind of local space that's going to make it much easier to align where the path of the laser shoots. If it's on the microscope and I've got the front and the back one on the microscope, it's a bit harder. I'm struggling to make this point forward. You actually kind of have to just hold the stem of the arrow. I figured this out. You don't hold the front of the arrow, you hold the stem of the arrow, which took me a little second to work out in my frustration trying to drag this thing over. I'll try the little origin of the laser. No, that's not going to help. Yeah, that's the one. And now we drag this back there. So that's easy. Now we need, because the grid's 2 meters, you could set that pretty much to 2 meters, and it'll check anything within a grid. I think I went a bit lower here, and it can cause some problems. I think I set it at 1, and we'll see how that goes. Or 0.75, I'm crazy. It's not going to reach. It's not going to detect anything there. So I'll try again at 1, and I still, for some reason, think it can possibly be not enough. The rear one, same process. It's just going to be a really easy check. It's going to give us a hit something signal, as in if that laser we can visualize there really easily hits anything, then we can cancel the movement forward or backwards. We do need another NOT gate. So basically, on forward and backwards, we're going to have the time is finished, so a turn's not being taken, and someone hits up, and the laser scope has not hit something. We're going to be good to move forward. Open up my laser scope there. Again, the finickiness, kind of frustrating at times. But here we go. There's our hit something signal. It can't go straight in. We need the NOT gate first. If it goes straight in, we're not going to be able to move unless there's something in front of us, which is kind of an odd way to control first-person character. Only if there's a wall in front of you can you move through the wall. So there's our little NOT gate. Gonna hook it up as well to our big AND statement. I guess you call it a statement. And now we've got that extra dimension of testing. Think it's gonna work automatically. Oh no, the issue might be with the laser scope in the end. We'll see that in a second. Duplicate that down here. Now, as I said before, there's quite a bit of wiring that you can do ahead of time if you're going to be copying these functions 4 ways, front, back, left and right. If you know the wiring by heart, it's just anything within that. You know, for example, you can have the extra NOT gate that runs into there. You can have the timer that feeds itself and feeds the second NOT gate. If you know it all ahead of time and you don't need to be spoken through the logic, I suppose, or you know, you can do a lot of this wiring right at the start and then copy it 4 times and it'll be fine. There, we've got a problem with our laser scope moving forward, but not backwards. I'm trying to move backwards into it and it's not working. There, try. But if we turn around, move forward, we do have a problem. So I think it was just a problem with the length on that laser scope. I'm not quite sure why. I'm checking here. It's all sorted. Like there's nothing wrong with that. You know, it's not hitting anything we can move. That's true. We just need to tweak I think we ultimately just need, you know, it's always good to run through the whole logic process again. This took me a second to figure out, but you know, I think you can just drag it up, make sure that it's giving enough range. Don't want to go over 2 meters really. But there, we can try it like that. Here we go. It's not going to let us move through, and we've got movement now. It's checking for obstacles when we move. It's allowing us to rotate and move around, and it's pretty much keeping our grid sound. You know, if all the settings are right logically, I don't see why it shouldn't keep that grid orientation. And we can now chuck it in one of our dungeons. You know, we've got a grid-based setup. It'll be awesome, and we can start to add some art and stuff like that.